Good afternoon, everyone. First of all, thank you so much for providing me an opportunity to present my research paper here at the first International Conference on Engineering Technology and Emerging System ICETES 2026. The title of my research is Digital Optimization of UK Supply Chains, a mixed method evaluation of operational efficiency, safety risk, and carbon reduction. We are two authors in this research. It's me, Muhammad Hamza Tariq, and with me, Dr. Aisha Anis. And in this presentation, I'm going to briefly explain about this research and starts with the introduction. The chemical sector is the backbone of UK economy, but it's currently faces a triple imperative. We are being asked to increase profitability and efficiency while maintain world-class safety under UK comma regulations and simultaneously hit net zero carbon target by 2050. Historically, these goals have been treated as a separate silos. Today, I will show how digital transformation allows us to treat them as a single integrated objective. Why this research method right now? The UK industry is struggling to balance operational effectiveness with environmental and regulatory requirement. The traditional model often view these as trade-offs. If you increase speed, you might risk safety. If you prioritize sustainability, you might lose efficiency. However, the emergence of Industry 4.0, specifically Industrial Internet of Things, artificial intelligence, and digital twins provide a unique opportunity to break these silos. Our research contribution is unique because while these technologies are known, but their combined effect on efficiency, safety, and carbon reduction has rarely been examined in a unified framework until now. Well, our study is grounded in three pillars. First, the triple bottom line, which moves beyond just profit, include people and planet in our industry. People mean safety and comma compliance, while planet mean carbon reduction, and obviously profit mean of operational efficiency. Secondly, we look at cyber physical system. This is where your physical assets like reactors and pipelines are mirrored in a digital framework. This allows for real-time tracking and automated decision making. And finally, we use supply chain resilience theory. This is not just about surviving a crisis. It's about using digital transparency to predict equipment failure and ensure environmental compliance before a problem even occur. And in methodology, to ensure our finding we grounded in reality, we use a mixed method, exploratory sequential design. And in our first phase, we conduct qualitative interview with 50 industry stakeholders, including plant managers and safety officer. We use thematic analysis to identify the primary barriers they faces. And in the second phase, we moved to quantitative approach. We surveyed UK-based chemical firm to ensure their digital maturity and use structural equation model to statistically validate how the maturity affect performance. These methodology ensure that our results are not just theoretical; they are backed by rigorous empirical data. Well, the result of our maturity assessment were eye-opening because there are significant digital divide in the UK. The large multinational corporations are doing well with the 75% of their assets integrated with digital tools. However, as you can see in the data, overall maturity is still low. For example, only 9% of the firms have high maturity in digital twin adoption, and 71% are still a low maturity level. Their barriers are clear. The cost of retrofitting brownfield site, a legacy infrastructure, and a critical shortage of specialized digital skills in the current framework. Now, let's look at the actual performance gains, our SCM analyze show that high digital maturity lead to 13.3% increase in operational equipment effectiveness, and this is driven by AI-powered predictive maintenance, which reduce unplanned downtime by by a staggering 80%. On the safety side, we saw a 32% reduction in high potential incident by using digital twins. Operator can run risk-free simulations of hazardous scenarios before they happen in the real world. Environmentally, we recorded a 7% reduction in specific energy consumption through advanced process control. This is not just going green, it's saving money. Predictive maintenance alone reduce maintenance costs by 28%. Well, what does this tell us? It proves that digitalization is the bridge between efficiency and sustainability. If we found a strong positive correlation between digital maturity and safety with the beta coefficient of 0.59. Furthermore, technologies like blockchain are now allowing us to track scope 3 emissions across the entire supply chain, something that was manually impossible before. We are moving for a reactive industry where we fix things when they break, and to a proactive industry, we are predict failure and optimize for carbon footprints even in real time. And to wrap up this, we cannot ignore the barriers. We recommend three policy interventions. First, the UK government should offer financial incentive or tax credit to help SMEs retrofit their legacy system. Secondly, we need a national data center for carbon traceability. And finally, we must invest in vocational program for data science and cybersecurity with the chemical sector. And digital transformation is no longer operational, and it's a primary pathway for UK chemical industry to remain globally competitive while fulfilling its duty to the planet and its people. Thank you so much for your time, and if you have any questions, and I'm more than happy to answer those questions. Thank you so much again.